A very good evening, everyone, and welcome back to Hudson Engineering Academy. It's me, your tutor Hudson, and today I'm going to introduce to you a new topic, that is a principal stresses and strain. In this topic, I'll give you the basic introduction, that is to say, what are some of the important formulas and some of the important basics required to handle this topic. To start, let's have a look at different cases that we have here. I'll say case number 1. Case 1, we're having when a particular member is subjected to, a direct what? Stress. Only one. Okay? So let us call that this one is sigma x and this one is sigma y. Along the way, as we go, I'll be explaining for you some of the terms, the terminologies involved in solving this. So this is sigma x, which stands for stress. Now, if we have a plane inclined, okay, and this is the angle, the oblique angle, let's call it theta. What happens is that if the question asks you to find what are the normal stress, then the tangential stress on this inclined plane. Okay? Now, the formula simply says normal stress, we are represented with sigma n, is given by an expression which is sigma x cos square theta. And then, tangential stress sigma t is given by expression which is sigma x by 2 sine of 2 theta. If a member is subjected to stress like this, these two expressions are quite important for you to calculate the what? The normal stress and tangential what? Stress. And what I would love to emphasize is that the angle in which this plane is inclined, let's say this is our plane, okay? The angle in which this plane is inclined should be the oblique angle, which is theta, with reference to the vertical. Okay? Of course, if we are to say this is the principal axis, the major principal axis, okay? So sometimes there will be questions that will give you the angle in which the plane is inclined to the major principal axis. So that is not used in the calculation. You have to use that information to find the angle in which it's inclined with reference to the vertical. Okay, so this is case 1. Let us have a look at second case. That is case what? Case 2. What if this member gets subjected to two mutually perpendicular, okay, two mutually perpendicular, like this. We're calling this one sigma x and this one sigma y. The same here is sigma y and this is sigma what? X. In this case, the same angle in which the plane, this is the what? The inclined plane. This is angle theta, which is the oblique angle. Okay? Now what happens in this case is that we have to find also the sigma n. A different scenario altogether from this. Now the formula that will help you to calculate this is sigma x plus sigma y by 2 and then plus sigma x minus sigma y by 2 and here is cos 2 theta. Okay? So this formula, once you've been given two stresses, one is like this and then another one is perpendicular. This is along the major principal axis. Okay? So in this case, the angle theta should be taken as this. This formula will help you to calculate the normal what? Stress in which this inclined plane, which is acting on this inclined plane. What if we want the tangential what? Stress. Okay? So the tangential one is going to be only this part, which is sigma x minus sigma y by 2. Instead of cos, here will become sine of 2 theta. Okay? Yes. So the moment you find this expression, you find this given member like this subjected to two different what? Stresses but perpendicular to one another, mutually perpendicular to one another, you have to use this expression. But if you don't have anything like a shear what? A shear stress, okay? Because as we see here, there's no shear stress. You are supposed to find the maximum stress that is acting in this what? In this case. Maximum shear stress only occurs when it occurs what? When, let me give you the condition, tau xy or tau yx is equal to 0. And when does it take place? We don't have any shear stress acting here, meaning that our maximum stress, maximum, will only be due to this what? Direct stresses, okay? Which it is going to be sigma x minus sigma y by 2. Okay? So this is how you would find the tau max. And what is its orientation? This one is oriented at angle 45. It occurs when the theta is 45 degrees. Okay? Well, so this is the second case. Now allow me give you the third case. The third case. So in this case, the third case happens when the member is only subjected only to shear. Let's say we have this, then this one will act opposite to this. Okay? Then if that is the case, I will have this one like this, then this one will act opposite to it. So if you're calling that this one is tau, since it will be cutting the y, sigma y, supposed to be yx, then this one is tau xy. Okay? The same here, you can write them. Now what happens is that since it is only shear which is acting, the formula for calculating the normal stress changes to, let's say, tau yx and tau xy, they're the same. They have the same value and we use it as tau. It's going to be sigma n equals to tau sine of 2 theta. Well, so that is for normal. What about for tangential? Tangential is going to be tau cos of 2 theta. So you have to understand the concept clearly. If it is on the shear acting, this is the expression. But let me take you to the fourth case, which is the combination of this one and this one. So if I combine the two, how will it be? Just bring shear and let it act here. This one. Yes. Then opposite to it, we shall have this. Okay. And this one. Then opposite to it, we shall have this. If you see clearly, this is case 4. I've changed. I'm just drawing this case 4. But I want to leave this to show you how we're taking it. So this is tau, since it's cutting y, so it is yx, then this is tau xy. Okay? Now, for the fourth case, change this to 4. For the fourth case, which is quite important and common in exam, you have to consider this with this one, then this with this one, because it is a combination. Okay? So, allow me write that first here. Okay? Normal for the fourth case. Okay? It's going to be the whole of this, which is sigma x plus sigma y by 2, then plus sigma x minus sigma y by 2. Okay? Then cos of 2 theta. Now you bring the one due to shear here, which is going to be plus tau sine of 2 theta. This is the fourth case. So take note of that. Then what will be that of the tangential one? Okay? So tangential one, this is going to be the whole of this one, which is sigma x minus sigma y by 2, then sine of 2 theta. Okay, and this one, in this case you don't have, but you subtract tau cos of 2 theta. So this is the fourth case. This one was for the third case. I just use it to as a reference to write out of the what? The fourth case. Okay, so I believe you have got up to this point. But to continue furthermore, let's have what we call the principal stresses. The principal stresses. So in the principal stresses, we're going to look at the minor principal stress and the major principal stress. Okay, so let me give you what is called the major principal stress expression. In the major principal stress expression, you have to consider sigma x plus sigma y by 2, and then plus root of, okay, sigma x minus sigma y by 2, and here is plus tau square. This is for the case of major principal stress. But what if the question wants me to find minor principal stress? This is given by sigma x plus sigma y by 2, and then here is minus. That's the difference only. The rest remains the same. Sigma x minus sigma y by 2. Mind you, this is square, sorry. So plus tau square. Okay. So in exam, once you're asked to find the major principal stress and the minor principal stress, these two expressions will help you. And all of them have been obtained from this one, fourth case. Okay. Now, the thing is, these principal stresses, we can have what we call the orientation. Because what I want is that, can I find how this plane is oriented? This plane. Remember, we have what we call the principal plane. It is given by the simple formula of 2 tau out of sigma x minus sigma y. So under this, you need to understand that whenever I want to get the orientation, okay, of the principal plane, the principal stress in this case is oriented at this expression. Now, what if we need the maximum shear for this case? The other case, we found that the maximum shear was only sigma x minus sigma y by 2, and it was oriented at 45 degrees. But for this case, what is the expression to find the maximum shear? Okay. If the question wants you to find the maximum shear, given this detail, given this information, the expression or the formula to find it would be, let me write it in, half into root of, okay, this is sigma y, take note of it, minus sigma x by 2 square, and plus tau square. All of them is under this one. I hope you are able to see it. So half root of sigma y minus sigma x by 2, then plus tau square. This is for maximum shear under this condition. Then what about its orientation? Is given by the formula tan 2 theta s, standing for the shear, is equals to sigma y minus sigma x by 2 tau. So take note of that. So if the question wants you to find the orientation for the shear, in this case, you need to take this expression. Okay? I believe you have got it clearly, because there's a different, these are all the 4 different cases I've discussed. Any other terminology, any other expression left, we shall discuss it in our next video when we're solving a problem. Okay? Yes. So if you have got one value of orientation, you can get the other one, because here it's saying 2 theta s. But that I will show you in our next video. Please don't miss that video. Thank you so much for watching this video till the end. Don't forget to subscribe to Hudson Engineering Academy so that you don't miss any of my video. Like, comment, and share with your friends.